So we just made the liquid in the thermoscope here less dense by heating it up with the hairdryer, and we watched what happened to the spheres. The little spheres with liquid in them actually dropped because the buoyant force was lowered when the density was lowered. So what I'm going to do is I'm going to try to increase the density by making the little container here colder. So I'm going to take a glove. I'm going to add some liquid nitrogen onto the glove because I'm afraid to put this directly on my glassware. So I'm soaking this glove, liquid nitrogen, and I'm going to take this glove and I'm going to just gently put this glove around, without freezing my hand, around this graduated cylinder, just trying to make the temperature of the cylinder colder. And doing so, I'm hoping I can make the density of the liquid greater, or make the buoyant force greater, because the density will increase. Remember, density is tied to the weight of the fluid that's being displaced. So I'm just going to wrap this around. I'm trying to make this glassware really cold. So by wrapping it around, my hope is that I can make this fluid cold enough that the buoyant force starts increasing, and now that my bulb will start rising because the buoyant force is greater. And if you look carefully by my thumb, you can see that the bulb is steadily starting to rise up, as Josh Groban would say. So again, just applying some very cold glove to this glassware, it's starting to rise up. Not a dramatic demonstration, but one that works. So you can see that bulb rising above my hand as I apply this cold glove that I soaked in liquid nitrogen, and it's making that bulb rise up as the buoyancy increases, as the density increases. Some people learn that the buoyant force is equal to rho GH, which is density times gravity times height. Okay, but all intents and purposes, the fluid being displaced is now heavier, so that buoyant force is now heavier as the density drops. Certainly not dramatic. Okay, I'm going to do this one more time. Make my glove even colder. Okay. And I'm going to wrap this glove around one more time and see if I can have the same effect. Very cold. So you can see the effect I'm trying to give here. And that cold water should make the buoyant force greater, and these bulbs should be rising above my glove. And you can see them not happening fast, but you know, the specific heat of the liquid certainly is low. Not as low as metals, so therefore it takes a little while, but you can see that they are rising. So as the liquid gets more dense, the buoyant force increases, and now these are definitely rising.